Okay, good morning, class. Real quick, hey, Zach, Zachary, I got your email, but you had sent it through different emails, so I didn't get it till late yesterday. So I replied to you today. So check
Yeah, I saw it. I just emailed you back.
Okay, okay.
4 o'clock we'll do tomorrow. Yeah.
Okay. I can also do today. It's up to you. Whatever's works better.
I have a lot of things to do for today. That includes studying because I have work today. I don't really have enough time for me to do this test today. So
okay, all right, we'll do it tomorrow. Thank you. Okay, everyone. Let's talk about the test. Let me see here. I've got the results for the test here. So to explain to you what you're looking at, on the left here is a chart. Everything in blue is the results from exam 1. Everything in orange are the results from exam 2. So on the left, you can see that on exam 1 and 2, we had the same number of A's. We had 1 B and no B's, or 1 B on exam 2, no B's on exam 1. The number of C's went up, the number of D's went down, but the number of F's went up. The class average on the test was a 63.3. The highest grade on the test was 98.3, and the lowest was a 20. So I don't know, what did y'all think of the test? I was a little bit surprised that it didn't go well. I mean, not that I'm saying it was easy, but given the, I guess, the review and the fact that there was no like surprises, it just I was looking at some of the students' work, and it just looked like students just had no idea what to do, and I don't know what happened. You know, like you had a reference sheet, you could have like given yourself hints and steps. Do y'all have any feedback for me? Because I'm kind of scratching my head right now. I mean, I feel like people are engaged in class, answering questions, you know, understanding things, but then you get to the test and it's just like completely different world. What do y'all think? I'm trying to figure out what I can do different for you all to help you do better on these tests. Some students' grades went up, some students' grades went down. I mean, we had students that got A's on the first test that got F's on this test. We had students who got F's on the first test that got A's or B's on this test. So it's like, it's all over the place. You know, so I'm really kind of trying to figure out what's going on. No comments, no feedback. I get something in the chat here. Let me see. Okay, so the fact that it was just a few questions is stressful. I mean, I get that, because if you get one wrong, it causes a big issue with your grade. Yeah, I mean, that is stressful. I mean, definitely, because yeah, I mean, I gave a test in my Cal 2 the other day. It was 5 questions. I mean, that's 20 points for each question, but it's impossible to give a longer test because you don't have enough time to finish it, you know? So these problems are long. I mean, you have to remember there's 2 college algebra classes, right, that we offer at Northwest Vista. There's the college algebra for students who are not going to do more math. That's math 13, 14. That's not this class. I teach that class as well. And trust me, I walk them by the hand through that class and get them through, because that's the end of the road for them, right? And if we have to slow down, we slow down. If we don't get through all the material, we don't get through all the material. It's very watered down. This class, my job is to prepare you for pre-calculus. And then most people who take pre-cal have to take Cal 1. I'd be willing to bet that almost everyone in here has to have calculus 1. And so, you know, something's going to have to change on your end in order to do better on exams. You can't do the same thing you've been doing if you're not doing well. Okay. I mean, I have a group of students here that are fine. Okay. This is really just, addressed to the students who've had D's and F's on both tests. Something has to change in the way that you're approaching things. I'm willing to change what I'm doing if I can somehow adapt something here to help you. I'm going to try something a little different today. We'll see. I mean, it's not going to seem very different. Just the way I'm going to present the material is going to be a little different. But I need feedback. I don't get a lot of you come to my office hours to get help. I think I've only had like 1 or 2 of you show up to my office hours. That doesn't mean that you're not going to get help from tutors, but I'm available. You have my cell phone number. You can reach out to me anytime. I'm here to help you, but you have to kind of meet me halfway and ask for the help. I did have a student request that I make a video of the review solutions, but I got the email too late. And so, I'm probably never going to do a video of me doing the solutions to the review for an exam. I'm probably never going to do that, only because it's just not realistic. I mean, like when you get to pre-cal and cal 1, you may not even get a review for an exam. You may just get like, hey, we're going to have the exam. This is the material it covers. Go study. And so to give you a review, that already is like, that helps a lot to give you a review. And then to give you the solutions is even more. And then to do a video, it's just, to me, it's just, it's up to you to take the review, take the solutions, try and figure out what's going on. If you can't reach out, get help, So anyone got anything else? I'm concerned about a group of you in here. I'm really, really concerned. I mean, it's not too late to recover your grade, but we really are at that point where now everything is going to be based on those next 2 exams. Yeah. I had to send out on Monday, I had to send out progress reports, and those are like midterm grades. And those midterm grade reports I sent out were before you took the test. So if I had to redo that, there would be a group of you that would be in a danger zone of not passing the class. So all that happens when I do that midterm reports, just to let you know where you stand. And so if you weren't passing, it would tell you, hey, you need to go get tutoring, you need to reach out to your instructor, get help, whatever, So, all right. No one has any comments or questions, or just general? I know the Zoom is hard. Okay. I know it's hard. It's different than being in class. It's very different, but. Okay. All right. Well, we continue then. So today we're going to get back on track in terms of, I'm going to have you doing your homework on the online system again. I'm going to just go back to that. And let's just see how that goes, if that helps, if we just consistently stay with that. So today we're going to cover 6.1 composite functions. Next class, we're going to cover 6.2 one-to-one functions and inverse functions. The homework that's due for today's class, 6.1, is going to be done online, using that website that we used in the beginning of class. The due date is Sunday night at 11:59 p.m. All right, for that assignment. So 6.1 composite functions. We're going to get started with that. And the way I'm doing this, the way the notes are going to be is I'm going to kind of like copy paste parts of the textbook, the ebook, into my notes, and then kind of work through the ebook notes for the section. And then I will incorporate some of the homework problems into the lecture as well. But remember, I mean, all of these lectures, all these notes, I post them for you, all the videos you can go back, so you've got to take the time Invest the time if you're struggling in the class to go back and review, rewatch something, go work problems out again. Okay, composite functions. So, I mean, before we begin, everyone should know, at least the general idea of a function, which we've talked about before. The idea of a function is that you have some like machine, we usually call the function f, some machine that basically takes some inputs, right, and then sends them somewhere, some output. And normally for this class, the function we're looking at takes a number in and spits a number out, right? Number in, number out. And that function can be, any function. We've looked at all sorts of functions in this class already. Now, the things that can go in, okay, is called the domain of f. I'm going to call it dom f. And then the things that come out are the range, which I'm going to call ran f. Okay, the domain is the input, the range is the output. All right. So we should all be comfortable with that idea. So when we talk about composite functions, a composite function has to do with when you're given two functions. Okay, so what if you have two functions, f and g, and we want to do this thing called composing them together? Then what we can do is we can create what's called the composite of the two functions. And we use a notation for this. This is the notation, f with this little o in between them. And the way you read that, like literally, if you were to say it, you would say f composed with g. Now, the notation that you're going to hear me use is not this. And what most textbooks or most people will say, math people or any tutors, they'll say f of g of x. Or let's just say f of g for now. F of g. F of g. So when you write this notation, f of g of x, this is the big thing you need to understand. What this means, okay? This means this. So f with the little o in it, then g in parentheses, and then an x in parentheses. This notation, this is just new notation, right? All it means is you're going to take the f function and plug into it the g function. So what we have, with the notation that we started here back at the beginning of this, if I gave you an x, it would go through this function f and come out as some value, which we call f of x. That's what happens when you send x through a function. With the composite function, we have two functions that we are composing together. And what it creates is like a chain, okay, like a chain of events. What happens here is first x starts here, okay, and then look at in the parentheses here, x. What function does that x go into first? If you look at this notation, who gets the x first? Can you tell from this notation? This x is getting plugged into which function? G or f?
G.
G, right? Because g is right next to it. So we want really to do g of x first. So that means we're going to take this x, we're going to send it through the g function, and that will come out g of x. And then after you do that, then the f function will take that answer and send it through. So this answer gets sent through the f function and comes out as f, well, with whatever the g of x was inside of it. So like when I'm in a classroom, normal classroom setting, what I do is I'll take half of the classroom and I'll say, hey, y'all are the f function, I'll tell them what they are. And then the other half of the class, I'll say, y'all are the g function, I'll tell them what they are. And then what we do is we practice sending things through this chain, all right, to see how things behave. So I'm going to try and simulate that right now. Let's say, half of y'all are the f function, half of y'all are g function. I'm giving y'all a specific example. Let's say the f function is 3x, and let's say the g function is x squared. How can we split the class up easily right now? How about this? Everybody who has glasses is the F function. Everybody who doesn't have glasses is the G function, okay? Got it? So if you have glasses, you're F. If you have don't have glasses, you're G. Glasses. No glasses. 2022, I swear. Okay. All right, you ready? So here's what I'm gonna do. I would like to do a composition right now where we do F of G of 2. Okay. I want to know what that is. Okay, I'm gonna do this over here. So what's F of G of 2? Well, by the notation here, this means that F is on the outside, G is on the inside. So this means F is on the outside, and then inside I put G of 2. Okay, so who's going first here? The F or the G?
Would it be G because it's
G's
right
going
next
first.
to
Okay,
2?
G of 2. Okay, so everyone without glasses, tell me what is G of 2? What happens if I hand you 2? What are you going to spit back?
4.
4, right? So G of 2 is 4. If you plug 2 into this G function, right? 2 squared is 4. So this becomes F of 4. Okay, and now the 4 is being plugged into the F. So F, my F people, what do y'all do with 4?
4 becomes 12.
4 becomes 12, right? It turns into 12. So visually, what happened here was this. With what we did here, what happened was we started with 2. 2 got sent through the G function, and the G function, people told me that the answer was 4, and then that number got sent through the F function, but when you plug in 4 into the F function, you get 12. So at the end of the day, 2 went to 12, right? That's what happened when we did the composite of these functions. 2 became a 12. Understand? I want to do a different problem. That's one problem. Let's do a different one. I'll do it over here. What about this? What's G of F of 2? Now, this is different, right? Do you see I switched the order of the G and the F? I switched the order. That changes the next line, which is where you actually put the G function on the outside and the F function goes on the inside. So now, who gets 2 first? Who gets 2?
Yeah.
Yeah, okay, so my glasses, someone who with glasses, tell me what is F of 2?
It's 6.
It's 6, right? You plug 2 into this function here. 2 times 3 is 6. You get 6. Now G gets it. So somebody from the G group, tell me what happens if I hand you the 6. What do you spit out?
You would square it, so it would be 36.
36, exactly. Okay. So the way that picture looks is this. We start out with a 2, but see that 2 went through which function first? The F, right? The F, and the F spit out the 6. Then that 6 went through the G function and became the 36. So do you see that this over here on the right, F of G of 2 is 12, but G of F of 2 is 36, right? So when you change the order of the composition, it could potentially change the answer, right? Any questions? I want to do another one. Okay, ready? I want to know what G of 2 is. G of 2. Well, use the same principle here. On the outside is G, but inside is G of 2, right? Because you have G twice. So my G function, those people without glasses, somebody tell me what would happen if I asked you to plug 2 into your function. What would you spit out?
It would be 4.
4. Okay, so now I have G, but inside of it I have a 4. And now you get that 4 again. You get to work with that 4 again, right? But the same function, G. So what happens to that?
Would it be 16?
16, right? You're going to square it again. So it's like what you did is this. You said, okay, I'm going to start off with 2. I'm going to send it through G. Well, G squares it, becomes a 4, but then you're going to send that answer again through G and squares and becomes a 16. And so if you have 2 functions, there's all these different combinations that you could do. You could do the f of G, you could do the G of f, you could do the G of G. What else could we do? What have we not done that we could do here?
F of F?
F of f, right? Why not we try f of f? Okay, let's try f of f. If we do f of f, and let's do 2 again. All right, we don't have to do 2. We can do any number we want, but I'm going to do 2 here. F of 2. This means you're going to have on the outside the f function, and on the inside, you're going to do the f function again of 2. So I like to think of this as like, it's like what we're doing is we're sending, I've talked about functions in the past as being like a car wash where you put a car through, it starts off dirty, comes out clean the other side. This is like you're sending a car through the car wash twice. The same, because it's going through the same function twice. So what would happen on the inside? What's f of 2? So what happens if you plug 2 into this function, into f?
Is it 6?
It's 6, right? 2 times 3 is 6. And now you're going to take that answer and you're going to plug it back into f again. So what happens if you plug 6 into f?
18.
18. Okay. So the picture here was, 2 became a 6, and because we multiplied by 3, and then it sent through f again, and it multiplied by 3 became 18. Okay, questions? I want to keep the same 2 functions, okay? Same 2 functions. I'm going to ask you a new question, and I want you to try and figure this out yourself, all right? Everybody work on this. See, the splitting y'all up in the classroom works much better than doing it the way we're doing it here, because then I can just like look at one side of the room and say, what happens if I give you all 2? And everyone says, oh, 6, and then say, here it doesn't work as well. But okay, here's what I want you to see if you can figure out and make sense out of. What do you think this would be? F of G of F of 2. I'm not going to tell you what that is. I want you to see if you can use what we just talked about, okay, to see if you can figure out what that is, what that means, and maybe it helps to like draw a picture. I don't know. Let's take 2.5 minutes. Okay, anybody want to tell me what they got? Come on, be brave.
108.
Would you get 108? Okay, anyone else get that? Got another person says 108. Anyone get something different than 108? Let's make sure that we understand this notation, okay? The way I like to do this is I start from the left and move to the right. So the outer function is going to be f. So that means I have f, okay? Inside of that, I have g. I'm going to do that in a different color. Okay, and now inside of that, I've got f again. And inside that f, I'm going to put the 2. You'll kind of see how that works? So we start with the f of 2. What is f of 2? Well, if we plug 2 into f, we get 6, right? So now this looks like this, f, and then inside of that, we've got g, and inside of that, we just figured out that f of 2 was 6. Now we're going to feed the 6 to the g. So if we feed 6 into this, we get 6 squared, that's 36. So now we've got f, and inside of that, all of that became 36. And then when we plug that into 36 into f, 3 times 36 would give you 108. Good. Okay. So when it comes to composition, if you give me 2 functions, when it comes to composition, I can put them together however I want. I could do f of g, like we did in the previous example, right? I could do, where is it? I could do f of g, I could do g of f, I could do g of g, I could do f of f, and then I could start going crazy. I could do f of g of f, I could do g of f, I could do g of g, and I don't only have to do 3, I could do 4 or 5, I could do f of g of f of f, g of g. It doesn't matter when it comes to composition. All right, now the ones that we are going to focus the most on in this class are f of g and g of f. These 2. These are the ones that we will be most interested in this class. And you'll see why when we get to the next section next week, when we're talking about inverses, we need that for something. Okay, so does everyone have the basic idea of what the composite of 2 functions is? The notation, what the notation means, and how it looks like a chain of events that occurs. We got that? Okay, I'm going to now look and give you a problem that looks completely different than what we just did, okay? I'm going to give you a table of values, and I'm going to ask you to find these things. So let me show you how the table works. Across the top are the values that you have for x. So these are basically your inputs, okay? These are your inputs. And then we have two rows that tell you what the output is for 2 different functions. So for example, let me read this first column to you and try and make this make sense right here. What does that mean? This means that this 11 right here means that when I plug -3 into the f function, it spits out 11. And then also when I plug in -3 into the g function, it spits out -8. So when you take this input, -3, into the f function, spits out 11. When you take -3 and plug it into the g, it spits out -8. Is that clear from the table? So what would happen if I plug 0 into g? What happens if I plug 0 into g? What do I get? Put your finger up. Plug 0 into g. I only see a few people putting, you get 1, right? Plug 0 into the g function. So you go across and down, it's this value right there. What happens when you plug 1 into f? What do you get when you plug 1 into f? Plug 1 into the f function, you get 3. Okay? Does that table make sense? The table makes sense? Anyone need me to clarify the table? Okay, so let's go and look at part A over here. What is f of g of 1? Okay, let's just go to the notation. This means we start with the f function on the outside. Inside, we do g of 1. So now what I'm doing is I'm saying, what's g of 1, right? I'm going to figure out what g of 1 is. Well, I look at 1, 1's the input. I go to the g function, right? So 1 is the input. I go to the g function. And when I do that, I get 0, right? So now what I have is f of 0, right? G of 1, that g of 1 became a 0. But now I still need to plug that into the f function. So when I go to 0 for the input and I go to the f function, what does it spit out? 5. So my answer is 5. I'm going to do part B, and then I think I'm going to let you try and do parts C, D, E, and F. So let me do part B over here. So for part B, I have f of g of 2, which means I start with f on the outside, and on the inside I put g of 2. Let me clear this stuff out. When I plug 2 into g, that means I'm plugging in 2 into the g function, and that's -3. So this becomes f of -3. And then when I plug -3 into the f function, it spits out 11. Do I need to clarify any of this? Does everyone understand how to read that table and how to find those values? You ready for me to let you try and do C, D, E, and F on your own? Or should I do one more? It's up to you. A response from anyone would be appreciated. Do you want me to let you do it?
Yeah, we can do it like by
Okay,
ourselves.
go
now.
try it. Try C, D, E,
Try 'em
and
out.
F. Try C, D, E, and F on your own right now. I'll give you a few minutes, and then why don't you do this on, if you have the ability on the poll, just click yes when you're done. Okay, when you're done, just let me know when you finished C, D, E, and F. We have about half of you that are done. All right, that's just about everybody. Anybody have any questions? All right, I'm going to call on people. Zachary, what did you get for C?
I got 0.
0, okay. Anybody disagree? Okay, good. We're just going to say it's right. Diego, what'd you get for D?
I got 0 as well.
0 as well, okay. Let's see, Lizeth, what did you get for E?
For E, I got 1.
1, okay. Anybody disagreeing? Everyone's good with these so far? Okay, Michelle, what'd you get for F?
7.
I'm sorry?
7.
7, okay. Anyone disagree? We're all good. Anyone have questions? Okay, good. All right, I've got another one for you. It's not going to be this, it's going to be the same idea, okay? Same idea, but a different sort of way of me giving you the information. Instead of giving you this table where you can see what the values are, I'm going to give you a graph. Okay, so the G function, okay, this is the G function. That's this one here. I'll do it in red. Okay, and then this one is the F function. And so let me do just part A. All right, for part A, it says find G of F of 1. Well, that just means I take the G on the outside and I do F of 1 on the inside. So the question becomes, what's F of 1, right? So that means, what do I get when I plug 1 into the F function? So I'm looking right now at the F function, which is this one. And I'm saying, what do I get when I plug 1 into it? Well, look on the x-axis. Here's 1, right? There's 1 right there. If I plug 1 into the F function, that means it's going to spit out this dot right here. And the y coordinate of that is -1. You can tell from this right here. This means when you plug 1 in, the out is negative. This is the out, right? So that means F of 1, the inside of that, should be -1. And now I'm saying, all right, now take G and plug -1 in. So now I'm going to focus my attention to find G of -1. I'm focus my attention onto the G function, which is this one up here. And I want to know what happens when I plug in -1. So I go to -1 on the x-axis here, and I find the point that's on the green function, the G1, right there. That's that point right there. And I look for the y coordinate, which is 3, which I can tell from this right here. When I plug -1 in, it spits out 3. So my answer here should be 3. Does that make sense? You're just kind of like following these points along. You want to try B, C, and D on your own? And try those? Okay, I'm going to clear all this out of here, all right? Because it can probably just be confusing with all my stuff up there. Try B, C, and D on your own. And oh, oops, too much. Let me just do it this way. Okay. All right, there we go. Okay, try B, C, and D. Let me know when you're done. Let's just go another 30 seconds. Okay. So I did B here. I did G of f of 5, plugged 5 into the f function first, which gave me a 1, and then took that answer and plugged it into the G function. 1 getting plugged into G gave me a 4. Who got C? Someone I have not called on. Can someone that I've not called on tell me what you got for C?
I got 1.
1. Okay, so I'm going to run through this. you plugged 0 into G first. So here's 0, you plug that into G and it looks like you get 5, right? Doesn't show it, but it looks like it's a 5. And then you take that 5 and plug it into F, and 5 into F gives you 1. So yes, I agree. Good. Someone else that hasn't responded want to tell me what they got for D?
-2.
Okay, -2. Okay, let's see. If you plug 2 into G first, plug 2 into G first, you get 2 out. And then you plug that into F and you get -2. That's right. Good. Okay, any questions? All right, we need to move along. So now what we're going to do is we're going to evaluate a composite function. Just to make sure you understand, I'm not going to do all of these. I'm just going to do maybe 1 or 2 of them. Here, I give you 2 functions. I give you the F function, and I give you the G function, right? And I ask you to do the composition, these compositions, right? So on part A, what I'm doing is F, and inside of F goes G, and inside of G goes 1. So first things first, I plug 1 into G. What do I get when I plug 1 into G?
Four.
4, okay, 4. And then if I plug 4 into F, be careful here, 4 into F. So maybe I should just write it out. It's going to be 2. I have to take the 4 and I have to square it, then subtract the 3, right? That's what I have to do. Order of operations, square the 4 first. 4 squared is 16. So 2 times 16 minus 3. 2 times 16 is 32. Take away 3, we should get 29. 29. Let's do C. I'll skip B, I'll skip D. Let me do C. So C is F of F. So F goes into F, and then inside there is -2. So what do I get when I plug -2 into the F function? Maybe I should do it on the side. I need to take -2 and plug it into the F function. So that should give me 2 times, let's see, -2 squared is 4 minus 3. So this should give me 8 minus 3, which should be 5. So that means I'm taking the F function, and inside of it, I am plugging in 5. So now I've got to plug 5 into the F function again. So this will be just 2 times 5 squared minus 3. So 25 times 2 is 50. Minus 3, we should get 47. Does that make sense, everyone? We've done that. We did that kind of to start, but these functions were a little more complicated with the 2x squared. Okay, I'll leave you to do those on your own. Let's move on. So I should point out, what we were just doing right now was evaluating a composite function. So we were given 2 functions. We were asked to evaluate it at different points, like f of g of 1, g of f of 1, f of -2, g of -1. So we were evaluating these composites at particular values. That's different than the next example. Here, we want to find a composite function and its domain. Okay, so this is we're in the same topic, but we're really switching now what we're trying to achieve. What the part A asks for here is for us to find what f of g is. Okay, that's what they're asking for. So what this means is if we put these functions together through that composition, we're going to get a new function, and we want to know what it is. So I'm going to show you the work for this, but I want to show you visually what we're trying to achieve here. We have a composition. we know that we're going to start by plugging x in which function will get x first. If we write f of g, which function gets the x first?
G.
G, okay? G, so G, it's going to go into G for, the x will go into G first. What happens if I plug x into G? So notice I'm not plugging in a number like 1 or 0, -2, but if I just plug in x into G, doesn't it just spit out 2x plus 3? Isn't that what it spits out? So this spits out 2x plus 3. But then I'm supposed to take that entire answer, right? This entire answer, and that gets plugged into now the f function, right? Because that's in the composition f of g, f is on the outside, so f gets that last, I guess you could say. G gets it first, G gets the x first, spits out an answer, and then f, you're going to hand f this right here, right? Notice you're not handing f x, you're handing the f function 2x plus 3. So what if I asked you to look at this f function right here and replace that x with 2x plus 3? That means you'd have to replace that x with 2x plus 3 and that x with 2x plus 3. And this is going to be very ugly looking, isn't it? It's going to be 2x plus 3 squared plus 3 times 2x plus 3 minus 1. Again, what I'm doing is I'm plugging 2x plus 3 in for that x into the f function, and that this is the blue is where the x's used to be, right? Go following this? That's visually that's what we're doing. Okay, visually that's what we're trying to achieve. But I'm going to show you how we do this algebraically, not visually. So I'm going to move this down a little bit. What we do is this. We start out with this and we say, okay, what this means is f is on the outside, inside is g, and we're going to hand g some arbitrary value x. Okay, so we're going to go ahead and just plug x into g to see what happens. So everything you see in that highlighted blue right there, g of x, that's just the g function. That's just what g of x is given to us in the problem to be, which is just 2x plus 3. I'm going to do that in different color. 2x plus 3, right? That's what g of x is. And now we hand that to the f function, right? So everything here in yellow gets plugged into the f function where the x's are. So it'll be that 2x plus 3 squared plus 3 times that 2x plus 3 and then minus 1. Again, the yellow is what the x used to be in the f. But since we're not handing fx, we're handing it 2x plus 3. We got to replace those x's with 2x plus 3. Now, this is the composite function. This is it. It's very ugly looking, right? But I'm not done. I'm going to do a little bit more. Watch. I'm actually going to take 2x plus 3 and I'm going to square it. I'm also going to distribute this 3 through 6x plus 9, then minus 1. So I distributed this through. And this I need to actually multiply out. So I have to do FOIL here. So I get 4x squared. Here to here, I get plus 6x. Here to here, I get plus 6x again. Here to here, I get plus 9. And then I still had over here plus 6x plus 9 minus 1. And this gives me a final result, 4x squared. Let's see, how many x's do I have? 6, 6, and 6, so 18 x's. And then I have 9 plus 9 minus 1, so that's 18 minus 1, that's 17. This is the composite function. This is what f of g is. So it's kind of like what's happening here is G gets X first, and then that answer goes into F. But by us doing all of this algebraically, we have a final function that basically does both of those like simultaneously. Okay, like that composite function has the same effect as going through the chain, except you don't have to go through the chain. Now, if I wanted to know what F of G of, let's say, 0 was, I wouldn't have to go through and first plug G into 0, plug 0 into G and then find that answer and plug it into F. I wouldn't have to do that. All I'd have to do is plug 0 into that. So what would happen if you plug 0 into this? What do you get?
17.
17, right? This is just 17. That would be our answer. But see, we don't have to go through that chain anymore. We don't have to follow it through both functions. It takes care of both. Are there any questions? Now we still have to do part B. And also it asks us for the domain. The domain. Now this is a part, when it comes to composition of functions, this is a part that confuses students and it can be tricky. When you talk about the domain of a composite function, you do not, I repeat, you do not just look at this. You have to look at the actual chain of events. So let me ask you something. Back down here in this picture, is there anything over here? Is there anything here that I cannot plug into G? And remember, when I say not plug in, what are the things we can't do in algebra? We can't divide by 0. We can't have roots of negative numbers, right? Square roots or even roots of negative numbers. So if our function has any fraction in it where X is in the denominator, or if we have square roots or fourth roots, we need to be careful. So when you look at this first function, G, 2x plus 3, that doesn't have a fraction in it, right? That's not, there's no X on the bottom. There's nothing I could ever hand this function G that it wouldn't be able to handle, right? So I should be able to plug any number I want into G. What about F, the function F? Let me erase some of this stuff up here. So when I'm looking at these two functions individually, this right here, the domain of that G is negative infinity to infinity. I can plug anything I want into that function. Also, if I look at F by itself, no fractions, no square roots, right? The domain of F is also anything, right? So since both functions can handle anything you plug into it, then when you start the chain of events over here, you can plug anything you want in. Anything you want can go in because G can handle it. And whatever G spits out, F can handle it because F can handle anything as well, right? F can handle anything, G can handle anything. So the domain of this composite would be, so this right here would be the domain of F of G. Now, I'll give you an example where the domain is not that easy. It's going to be a little more complicated, as you'll see, but you all right with this? I'm going to try and give you a different example. I'm not going to do the part B here. I want to give you a different example to kind of get you thinking about this. What if I told you this? What if I told you that F of X was X, okay? And I told you that G of X was 1 over X, okay? First thing I want you to find is F of G of X. Okay, let's find this. So this means F goes on the outside, G goes on the inside. So when I'm doing this, trying to figure out what it is, so I should do part A. I want us to find this, sorry, find that. So inside of F, I'm going to plug in G of X. Well, that's just the function 1 over X, right? 1 over X. And then what am I doing here? What am I going to do with this? I'm going to take 1 over x and plug it into the f function, right? So I'm replacing that x right there with 1 over x, right? So what does it turn out to be here at the end? If I replace that that x with 1 over x here and here, I just get 1 over x, don't I? So my answer here is 1 over x. So let's talk about the domain of this. I'm going to draw a picture again. Here's x. X goes into g first. G spits out 1 over x. And then that goes into the f function, and that f function is just going to spit out the 1 over x again. What can I not plug in? What am I
0.
not allowed to plug in? I'm sorry, what was that? What?
Is it 0? Because
0. I can't plug 0 in, right? When you look at G, when you look at this domain right here, the domain of G, right? The domain of G is everything except 0. You cannot have 0. If you plug in 0, you've got a problem, right? You have division by 0. So 0 can't go into G, right? Now, what about this function over here? What about f? What's its domain? Well, do you see any fractions or anything? No, right? So this domain can be anything. So what is our answer? Is our answer that we can plug anything we want in when we're talking about the composite? Is the domain of the composite, is it this domain or is it this domain? Like, what are we looking at here? You have to look at this chain of events, right? Here, x can't be 0, right? Because you can't plug that into G. And since you can't plug 0 into G, you have an issue, right? Like that's x can't be 0. That's your domain restriction. Now, once you get here, there's no domain restriction because f can handle anything. So this would just be x isn't negative. I mean, sorry, x isn't negative 1. X isn't 0. All right, let's go back. Let's do we did this one. Let me look at another example. Yeah, this one's more complicated. I think this one's worth us looking at. Okay, so I want us to look at this composition. I want us to find the domain of f of g. Well, first things first, let's find what f of g is. So f of g means I'm going to take f inside of that. I'm going to plug g inside of g. I'm going to plug x. Okay, so I leave the f alone. What do I replace g of x with?
it's the 4 over x minus 1.
4 over x minus 1. Good. Now, that 4 over x minus 1 is now going to get plugged into the f function. So wherever we see an x in the f function, I replace it with this yellow piece. So this is going to be ugly. This is going to be, what is the f function? It's 1 over, but see, I'm replacing this x with all of this. So it's 4 over x minus 1 plus 2. This is a good time for you to ask the question because this usually confuses students, that what I just did there. So I replaced the g with what g is, and then I took that g and I'm going to plug it into f, which means this x gets replaced with that g, which means it gets replaced right there. See, this used to be the x, right? That used to just be x like this, but I'm replacing it with the yellow part instead. So it's a little more very complicated looking, right? That is your composition. Now, algebraically, I'm going to clean this up. All right, watch me clean this up algebraically. The first thing I'm going to do is in the denominator, I'm going to get a common denominator. So I'm going to rewrite that 2 as 2 over 1. I'm going to put these two fractions together. So to do that, I have to get a common denominator between the two, which means I have to multiply this by x minus 1 over x minus 1. Right? If we want to add two fractions together, we have to have the same denominator. So that's what I'm doing there. I'm going to put these two together. I have to rewrite the 2 as 2 over 1, so I create a fraction, and then now I have the same denominator. So my next line would be 1 over, okay, I have 4 over x minus 1 plus, let me distribute the 2 through, 2x minus 2 over x minus 1. Now that they have the same denominator, I can add those together. So I get 4 plus 2x minus 2 over x minus 1. Right, same denominator, just add up the numerators. 1 over, okay, what do we get up here? Just 2x plus 2? Yeah, 2x plus 2. The 4 minus 2 is 2 over x minus 1. And now an interesting property of fractions. If you ever have 1 over a fraction, that is the same as just the reciprocal of the fraction. 1 divided by a over b is the same as b over a. That's just a property of 1 over a fraction. So do y'all see that I have 1 divided by a fraction? So I can basically just flip this over and make this x minus 1 over 2x plus 2. There we go. This is what f of g is. Questions on that algebra? Questions on the way I did that? Now here's the danger zone. We are being asked to find the domain of the composition, right? The domain of the composition. Right now, when you look at this composition right here in yellow, when you look at this, is there any value of x that you cannot plug in?
1.
1, if we plug in 1 into this, we'll get 0 on the top, right? Is it okay to have 0 on top? It is, right? It's okay, Lizette. Good, you're at least looking, right? It's okay if we have 0 on the top. We just can't have 0 on the bottom, right? We can't have 0 on the bottom. So what would make the bottom 0? So let's just kind of think about that. What would make 2x plus 2 equals 0? What would make that happen? You can just solve this, can't you? Just move the 2 over, divide by 2. Wouldn't you get -1? So do y'all agree that right now I cannot plug in -1 or I'm in trouble? Yes? So when I talk about the domain of f of g right now it's looking like x cannot be -1. It can be anything else but -1. It appears that way so far. Y'all agree? But that's not the only problem that we're going to have. Okay, and here's why. I need you to go back and I need you to think about the chain of events that happens, right? The chain of events that's occurring here is this. We know that x goes through what function first? According to what we're trying to find, f of g, it's going to go into what function first?
G.
G, okay. G will spit out this right here, 4 over x minus 1. Now, when we plug that into the f, we know the answer will be x minus 1 over 2x plus 2, right? How do we know it's this? Well, we did all the algebra. Do y'all see it right here? So we know right now that x cannot be -1 because of our final result here. This told us here that x cannot be -1. But Lizette was actually correct. When Lizette said x is 1 won't work, that was actually true, but not because of this, right? Not because of that, because of this step right here. When we try and plug X into G, what can G not handle? Look at G. You don't ever want that bottom to be 0, right? So you better not plug in 1, right? You try and plug 1 in here, you're going to get division by 0. So even though 1 doesn't cause a problem in the composition at the very end, it causes a problem at the first step of the composition when you try and plug the X into the G. So we have to go back and we have to add to this also, X cannot be 1. So what's the moral of the story here? How do you do a problem like this? What you do is you do the composition, right? You do all this, you do all the algebra, right? And then what you do is you try and look at the domain of that, okay? And you figure out what can or cannot go into that. And that will give you one of the answers. If there's an answer, that'll give you an answer. But then you must always go back and look at the domain of the first function that got the X. And that in this case was the G function. You have to make sure you remove that point as well. Now, if you're confused on that, that's okay, because what I'd like for us to do is I'd like for us to do it the other way around. Okay, I'm going to make a, oops, sorry. I'd like for us to take this same thing, okay, the same problem, but I'd like for us to do, I want us to find G of F, okay, and the domain. Okay, so I'm not doing that or that. So why don't you take a moment, see if you can at least do this part, get G of F of X, get that going, okay? See what this turns out to be. Try and see if you can clean it up algebraically. And to help you, I'm going to bring up, where's the one we just did? I think I'm going to copy this part right here. Here's the one I want you to do. I'm going to put that here just to kind of keep a little reference on how I put those fractions together. Yours is going to be different than this, but that'll be like a little reference for you if you need it on how to put things together. See how you do with this. Take a few minutes. Let me know when you're done. So 2 of you say that you're through, that's fine. I've started working it out here, just so you can see it. I'm gonna go another maybe minute. All right, let's talk about this. I'm asking you for G of F in the domain. So G goes on the outside, F goes on the inside. So we're reversing what we just did in the previous problem, the position of which gets it first. So we replace f of x with the function f of x, which is this. Then we take that in yellow and plug it into the x on G. So I replace that x right down here with the -1. I replace that entire x with this fraction. And now I've got the composition. I just need to clean it up algebraically. So I need to get a common denominator between these two. So I rewrite this 1 here as 1/1. And I multiply the top and bottom by x plus 2. Then when I put these two together, very important that you put parentheses around the x plus 2 because you are going to subtract the entire numerator, which means the minus sign must distribute to both the x and the +2, which is why in the next line I have 1 minus x minus 2. Are there any questions on that step? Now here I did 1 minus x minus 2, that gave me negative x minus 1, and then I flip the fraction. So one way you could look at this is, like, imagine that 4 wasn't there. Imagine that was a 1. You would just flip the fraction over. But because there's a 4 there, we're just going to slap that 4 next to that fraction that's flipped over, which is why there's a 4 on top with the x plus 2. And then I look at that and I ask myself, okay, what would cause a problem here? So I set the denominator equal to 0. I move things around algebraically and I get x is -1. So that tells me if I try and plug -1 in here, I'm going to have an issue, right? Negative -1 is +1, -1, that would give me 0. So for sure, x cannot be -1. But what else do I need to look at? I need to look at one more thing. What do I look at?
The f of x.
The f of x. You got to go back. Remember, G was fed the f of x. So x went into f first. So I've got to go back to the f of x right here. And I've got to ask myself, what can I not plug into that? Right? Well, look at it, right? What can you not plug in?
-2.
-2. So the domain of my composition will be that x cannot be -1 and x cannot be 2. Sorry, -2. Now, just so you know, when you're doing your homework, they may want this in interval notation. So if this is -2 and this is -1 on a number line, we don't want those values, right? We don't want them. We can have anything over here, anything in between, and anything to the right. So to write this as an interval, it would be -∞ to -2, union -2 to -1, union -1 to infinity. So that basically says everything on the number line, just pick off -2 and pick off -1. Those two cannot be part of your answer. Questions? Okay, I'm gonna move on. I know some of you are still copying this down, but. All right, so for this one. Yeah. All right, this one says what we're gonna try and do here is show that two composite functions are equal. In other words, we're going to show that when you do the composition one way, f of g of x, you get exactly the same answer as when you do g of f of x. So let me do this. First thing I'm going to do is f of g of x. All right, f of g of x. Find that first. That means f's on the outside, g goes in and gets x first, which means leave f on the outside, replace g with, ooh, that ugly fraction. And now I take that answer and plug it into f. So that means I'm going to be taking this, plugging it in right there for the f function. So that means I'll have 3, and then I'm replacing the x with x plus 4 over 3, and then minus 4. Let's try and clean this up algebraically. Do you all see that these 3's would cancel? Right, the 3 on the outside would cancel with the 3 in the denominator there, which would leave me with just the x plus 4. But then I'm going to subtract 4. And when I subtract 4 from 4, I get just the x by itself. Okay. That's what f of g of x is. What we're going to try and show is that we will get the same exact answer if we do the composition the other way. Now, generally speaking, this does not always happen, okay? When you switch the order of composition, it does not mean that you're going to get the same answer. I think we showed that on the last problem, right? The last one we just did. Right, when we did this one, we had switched it to g of f. We got a different answer than when we did f of g. So generally speaking, this is not always the same. Okay, so g gets fed the f function. The f function is 3x minus 4. And now we're going to take that that f function and plug it into the g for the x. So I have the 3x minus 4 plus the 4, divide the whole thing by 3. So again, that 3x minus 4 was plugged into the g function right there. Y'all see what happens on the top with the 4's? All you're left with is 3x on top over 3. And then do you see those 3's cancel out? And you're just left with x. And notice these are the same. For these particular functions, when you do f of g of x, you get the same answer as when you do g of f of x. So the order doesn't change what the composition is. Again, doesn't always work that way, but for these it did. Okay, let me look at the next question. Yeah, so this is a different topic. Yeah, so let me see what I can do in 8 minutes here. All right. For this next example, we want to find the components of a composite function. In other words, what they're giving us here, this h of x, capital H of x, they're telling us that that is two functions put together already. They've already put it together. And what you're trying to do is figure out what two functions were put together to give you that. Right? That's different than what we've been doing. What we've been doing is I give you two functions, ask you to compose them, tell me what the answer is. Here, I give you the answer and I say, go tell me what the two functions they came from are. So they're trying to get us to figure out what two functions we composed, f and g, to get this capital H function. So the way that I look at this is this. By the way, this is a very important calculus concept. It's actually in Cal 2, you need this quite a bit. All right, so the way I look at this is this. What I'm seeing here is I've got this yellow function, x squared plus 1, right? That's like a quadratic. But then it's being raised to the 50th power, right? It's being raised to the 50th power. So the inside function is the yellow one, and the outside function is the raising of a 50th power. It's not multiplying by 50, it's raising to the 50th power. So they want us to somehow look at this as being this composition, f of g. So g is the inside function, and f is the outside function, right? That when you write f of g, g is the inside, it gets the x first. The f then goes and does something to it. So let me write down what the two functions would be, and let's see if you follow this. Here it is. Here's my answer to this question. My answer is the inside function is just x squared plus 1. Okay, it's just the thing I see on the inside. But then that gets fed to another function which takes things and raises it to the 50th power. So this function raises things to the 50th power. That's my answer. Now you could check it, couldn't you? You could check this. What would f of g of x be? Let's see. So if you take the g function, which I'm saying is x squared plus 1, and you take that g and you plug it into the f function right there for x, then wouldn't you get x squared plus 1 raised to the 50th, which is this. So these are the two functions that are composed to give you capital H. I'm going to give you another one. What if I tell you that capital H of x is equal to the square root of x cubed plus x plus 1? And I want you to find the two functions f and g so that when you compose them, f of g, you get that capital H. So that means you're going to need to find me a g function and an f function. What do you think? Jose? Are you with me?
Yeah, I am.
You following this?
Yep.
Okay, so what's the g going to be then?
G. Let's see. Would it be
G is going to be the inside function. So what is the inside function to this?
x cubed plus x plus 1?
Okay, good. Now, the outside function is what? So you've already said like, okay, that's the inside. Then what would you do with that after you figure out what x cubed plus x plus 1 is? What would you do? What would be the next step that you would have to do?
Figured out what fx is.
Yes, but I'm saying algebraically, like if I asked you to plug a number in here, you would do all this in yellow first, right? And then after you're done with all that, what would you do? You'd have to take the square root, right?
Like the square root of it.
Square root, right? So the outer function is just the square root function.
Okay.
So you'd say here, square root of x.
Okay.
Y'all following this? I'll do one more. What if we had h of x equals 1 over the square root of x squared plus 1? And I want you to find f and g so that f of g equals capital H. Now, I'm going to warn you on this one. Not warn you, I'm going to tell you that you can actually, there are different answers that would they would be correct, depending on how you want to visualize this. So you have an inner function and an outer function. Who wants to give me the inner function?
Is it just x squared plus 1?
Okay, we can do that. X squared plus 1. That's fine. We can do that. X squared plus 1. But then what would your outer function be?
1 over the square root of x.
Good. 1 over the square root of x. Perfect. That would work. So if you take, basically, if you take this x squared plus 1 and you plug it in right there for x, then you would get back this original thing, wouldn't you? That's one way to do it. Now, there's another way. Can someone give me another way of doing it that would still be correct? It's a different inner function. What is it?
Square root of x plus 1.
Yeah, take the whole thing. Take the square root of x plus 1, or sorry, the square root of x squared plus 1. Take that as your inner function. Okay, good, Diego. Then what would your outer function be?
1 over x.
Just 1 over x. See, because if you take this entire thing, right, and plug it into that x, you get this. Or you could take just the inside of the root part and plug it into 1 over the square root of x, and that would work. Those are both correct. I do not think there's another way of doing it. Okay, look, do your homework to the best of your ability. I think that you're going to run into some issues, okay? I think you will. But do what you can, and then when we come back, if you have questions on your homework, I'll be happy to answer them. If not, come into my office hours, reach out for help, whatever you need to do, okay? Y'all have a good weekend.
Thank you.
Thank you.
Thank you, Professor. You too.
All right, y'all have a good one.
So,
Yes?
because I came in late today. When will the video be posted, do you know? Or like, do you know like a time when it's posted
For what?
for the class? Because I came in late today, so I need to watch it.
Yeah, it takes Zoom a little while to figure it out, to like get it to me, and then I have to upload it to YouTube. So it probably won't be till after 1 or 2.
Okay, for sure. I'll just
Yeah,
do
'cause
it.
I have a class right now that I'll be
Okay.
in until about 1.
For sure. Yeah, okay, then I'll watch it tomorrow morning.
Okay.
All right.
Sounds
you have a
good.
good one.
All right. Oops.